when it comes to rational expressions, we have to be able to do arithmetic with them. Just like we were able to add, subtract, multiply, and divide, and simplify fractions, we're going to have to add, subtract, multiply, divide, and simplify rational expressions. So let's just start with simplifying. Remember, in order to simplify a fraction, what we need is to cancel out any common factors. So when we saw something that looked like 50 over 75, we really looked at it as 25 times 2 over 25 times 3. Then, because the numerator and the denominator both had this common factor of 25, they canceled each other out, and we were left with 2/3. That's the process that we want to use now when we're talking about rational functions. Here we have a factored rational function, where in the numerator there's this common factor of x minus 5 that's the same as what's in the denominator. They're going to cancel each other out and leave us with x minus 3 in the numerator and just x in the denominator. The reason they canceled out was because they were being multiplied right here and right here. Because what canceled with division? Multiplication. What canceled with multiplication? Division. And that's why they cancel each other out. What doesn't cancel with division is adding or subtracting. Because when you look at this, part of you kind of wants to cancel these two x's, and you can't do that. Right? Because what cancels with division? Not subtraction, but multiplication. Lots of times the rational expression isn't factored for you. So you need to take the extra step and factor the numerator into x minus 6 times x plus 2. And in the denominator, factor it into x plus 6, x minus 6. Now that it's all factored, look for the common factors that are in the numerator and the denominator. And I see there's an x minus 6, and there's an x minus 6. What we're left with is x plus 2 over x plus 6. You can't cancel the x's, and you can't take a 2 out of the 6 and 3. Right? Because what cancels with division? Multiplication, not addition. Right? So be careful of that. This is our final answer. Remember when we multiplied, it's implied that we want to multiply and then simplify our expression. But there's nothing that says that we have to do it in that order. See, we got kind of good at looking at this multiplication problem and recognizing that 4 and 32 share that common factor of 4. So we take a 4 out of there, cancel the 4 out of the numerator and denominator, and we're left with 1 up here and 8 right there. And we do the same thing with the 25 and the 15 because they both share a common factor of 5, and we're left with 3 in the numerator and 5 in the denominator. Now we do this easier multiplication of 1 times 3, which is 3, over 5 times 8, which is 40. So we want to kind of follow that same protocol when we're multiplying some rational functions. Look for things to cancel first before we start multiplying things out. For instance, 2 goes into 8 4 times. Also, 4 and 4 will cancel each other out, leaving us with just a 7 as the only number that's left. Then when we look at the x's, I want to change my color here. This x down here is going to cancel with one of the x's in the numerator. So that'll leave us with an x squared right there. Also, for the y's in our denominator, we've got 1, 2, 3 of them. So that will cancel with all 3 of those y's. Now we look at what we have left. Like I said, we just had that 7 left right here. Between the x's, we got an x squared and an x to the 4th, which is x to the 6th. And for the y's, all we have is this little y. So that's how we can cancel first and then see what we have left. Obviously, sometimes we're going to have to do the factoring. So let's do that. Just factor each piece. Instead of trying to multiply this thing out and then look for common factors, which is ridiculously hard to do, just take each piece and factor that. Like right there is a common factor of 3x, which leaves us with 1 minus x. In the denominator, we've got x plus 5 times x minus 1. In the next fraction, we have x plus 5 times x minus 4, and 3x is what's left in the denominator. Now start looking for things to cancel. So a common factor that's in the numerator and the denominator, you probably recognize the 3x right away. Those two cancel with each other. The x plus 5 cancels with each other. And you kind of want these two to cancel with each other, but they don't, because they're not exactly the same. And when it comes to subtraction, order matters. So let's rewrite what we have here and maybe take a closer look at it. For instance, in the numerator of this multiplication problem now, we have this 1 minus x and the x minus 4. If I want to get that 1 minus x to say x minus 1, what we have to do is factor out a negative 1. Look what happens if we take a negative 1 out of here. Then that positive 1 turns to negative 1, and that negative x turns to positive x. So positive x minus 1. And then we're also in the numerator left with x minus 4. In the denominator, the only thing that's down there is the x minus 1. So when we factored out a negative 1, we rearranged the order of this subtraction, and now these two can cancel. Now we can finish up our multiplication by distributing this 1 back in over here, and we end up with negative x plus 4. Let's try one more. X plus 2 over x cubed minus 27 times x squared plus 3x plus 9. And you realize that it's not factored yet. So we go ahead and we'll start factoring. X plus 2 can't factor. X cubed minus 27, it can factor. That's the difference of two cubes. And you might be out of practice with that, but remember, you take the cubed root of x cubed minus the cubed root of 27, and what we're left with is square together square. So square the x, multiply the 3 and x together, and then square the 3. And we've already used our minus sign, so we're only left with pluses. And that's being multiplied by x squared plus 3x plus 9, which as a fraction is all over 1. Now, look for the common factor, which is just this big guy right there. And the only thing we're left with in the numerator is x plus 2 over x minus 3. No more canceling can happen, so there's our solution. So, in simplifying through multiplication, the process is still the same as that we would do with numbers. One thing that we have to look out for is we've got to fight that urge to try and cancel these x's, because adding and subtracting doesn't cancel with division. And the other thing we have to look out for, it happens right here. When we want to switch the order of subtraction, we have to factor out a negative 1.